What do you say? What do you say? What do you say? Which one did you start with? Probably, I'm guessing.
Just let's start from the very beginning.
Well, right, I would too. I think it's the easiest. I think it's the easiest to figure out what the chance of no girls is. And there's not much of a chance of getting no girls, is there?
No.
Because basically you have to have Bertha be a boy, Marge be a boy, Nancy be a boy, and Mary being a boy. So it's a 1 in 10,000 chance. It's a 1 in 10,000 chance. It's basically not going to happen, essentially. Here is what I was able to do in the store when the guy told me there's a 90% chance of girls. I went down to here, and I said, well, that means there's a 1/3 chance I've got a rooster. So my 1/3 was based off of this one. Did you guys do this one next, I'm assuming? So Bertha's a boy,
Yeah.
and Nancy, and Marge, and Mary. Fair enough? And you guys got, I'm probably 6, 5, 6, 1. I was cheating and looking at your guys' work. Yeah. Now, of course, that's not 2/3, but it's ish 2/3, isn't it? It's close to 2/3.
But it's getting harder.
It is. Look at that last column, or that last entry. This row is going down each time I add a bird. Because every time you add a bird, look at the pattern. Every time Max grabs a bird out of the bin, you're multiplying this number by 0.9 again. So if you had 5 birds, it'd be that times 0.9. 10 birds, 0.9 of the 10th, which drops it down significantly. As a matter of fact, we'll answer this question on Wednesday. How many birds do you have to buy until this is no longer the most likely outcome? We'll come back to that. We'll come back to that on Wednesday. Okay, that's the next page. So we know if this is 65.61%, the rest of this has to add up to whatever's left. So what did you guys do next? 1? Love it. So for 1 to be a girl, you're going to have 3 boys and 1 girl.
Yeah, and multiply by 4.
And multiply it by 4.
Yeah.
Multiply it by 4. We can put that in red. Multiply it by 4 because either Bertha's the girl, or Mary, or Marge, or Nancy. 4 possibilities for that. So that's 0.0009. So that's 0.0036. Did I do that right in my head?
Yeah.
Very unlikely. Very unlikely. Probably won't happen. You most likely won't get more roosters than hens. Did you guys do this one next, the 3? Or did you go to the 2 next? Straight down now? Oh, let's do the 2 then. Let's do the 2. So the 2, you have to have 2 boys and 2 girls. How many ways can that happen?
4 ways. 8?
Let's come back to that. Let's come back to that. It's more than 4. Less than 8. Let's come back to it. Let's come back to it. Hang it. Let's come back to it. Let's come back to it. Let's come back to it. Let's come back. Let's come back. Let's come back. Let's jump down to 3. Let's jump down to 3.
So
3 is 0.1 and then 3.9, correct? It's 3.9, correct? Now, how many ways can that happen? Be brave, be brave. That is 4, isn't it? Because if you're going to have 1 boy, that can happen the same number of ways as having 1 girl. Either Bertha's the boy, or Mary, or Nancy. So this is again 4. This guy's again 4. Okay, that's again 4 right there. Hang tight, hang tight, hang tight, hang tight, friends, hang tight, hang tight. So it's 0.9, 0.9, 0.9. That's I'm going to cheat, that's 0.72. 0.072 times 4 is, what is that, 28.8? Did I get it right?
2916.
0.916. Crap, I didn't carry enough. Thank you, thank you. 0.2916. That's pretty likely. That's pretty likely. Which means getting 1 boy in the box is a pretty big possibility. Now we know what has to go up here. We know that whatever this adds up to, taken away from 100%, has to be what the last probability is, correct? So what does that last probability have to be? Go ahead, Jen, you got it right there? What is this last probability? I'm sorry, I saw you look at your TI. Oh, Jenny! What is this last? Going with the 1 minus trick.
Oh, I didn't do that.
Okay, pretend this is your exam on Wednesday, and I ask you to find this probability right here. Can we do it?
yeah.
Hell yeah, we can. Add up the pieces you already have,
So like 4%.
and take it roughly 4%. What do you got? Give me 4 decimals. 0.0486?
Oh, I didn't have it.
So almost 5%, almost 5%. Pretty close to 5%. Now here's the deal. Haley, and everybody, this is a great question. If this was 4, that wouldn't equal 4.98%. It would be a little bit too shy.
Yeah, because that's, I was adding up, it's like 0.9.
You're shy a little bit, right?
Yeah.
So the question is,
So it's like, oh, just
what
round it.
number has to... Dude, I'll just round it. That's awesome.
That's what I did.
Remember, but careful. When you get too far away from one, we have to start going, wait. Check it out. Let's figure it out. We want 2 boys and 2 girls. My fingers represent 2 boys. You ready? Where could the boys be? These 2?
Yeah, or low.
These 2?
Yeah.
Or by
And those
Yeah.
2,
4.
and those
Okay.
2 are diagonal.
5,
Yeah.
6. So there's 6.
And that's it. There's 6 ways, right? There's 6 ways.
So 6.
So that's why the multiplier is 6. It's not 4. 4 is too low. 8's too big. 6 is perfect. 6 is perfect, right?
Interest.
And that gets you to exactly 4.86%
And we
for
probably
2.
have got a formula.
We do, but you're not going to have to worry about it. And this is why I just gave you guys, there is a formula. There is a formula for knowing that that is 6. And knowing what it is for the next. And what I've decided, and this works pretty well, I've got a quiz put together, probably for week 9, that actually kind of walks you through the formula, because it's mathematically beautiful and practically useless. I say that because it's very often convincing and useful to know what the number is, but memorizing the formula to get that number is not that important. I like to give you the quiz once you've turned in your 3rd project. It's called a binomial coefficient. This number is called a binomial coefficient. There's a really cool pattern. I don't want to jump on you right now because with 5 minutes left, that's really unfair. There is a cool pattern. It's mathematically gorgeous. It's related to something you've been doing all your lives in algebra classes. I mentioned this earlier. Awesome, very cool to see, not cool to memorize. Totally useless to memorize. What you guys did today, when you went from flock 1 to flock 2 to flock 3 over to flock 4, is far more useful than memorizing the formula to generate. Here's the deal. Elena brought up a great question. She said, what if your flock had 10 birds in it, right? Well, you'd have to do this from 0 to 10, and then figure all these things in the middle. Now, it's not that hard right away to see that the first coefficient right here will be 10. I mean, it would have to be 10, because if you have 1 girl, there's 10 places for that 1 girl to be. What would the coefficient for the next one be?
8.
I believe it would be 20.
I don't get how you figure that
Oh,
out.
yeah, no,
You're-
10.
Hold patience, my friend, on that one. Patience on that one, I promise you. But I guess my quick and easy answer is for the next week and a half, you don't have to worry about figuring it out. And for the 2 weeks after that, you don't have to worry about it either. The quiz I will post, I'm going to post 2 quizzes, I think, in week 9. One of them is going to be an optional quiz to discover where that number comes from. It's called something called Pascal's triangle, and it's beautiful. But here's the deal. Grab your calculators. Let me close with this. I just gave you guys a bunch of programs while you were working very diligently to come up with that flock distribution. Let me show you how one of them works. Let me show you how one of them works. And we're going to come back to this. If you don't quite get this right now, we'll come back to this on Wednesday for sure after your exam. So everybody fire them up, okay? Press the PRGM button, program. Okay, program, PRGM. Now I don't think you have as much crap as I do in here, but find the one that's called dist fill. Dist fill. So PRGM button, dist fill. I will definitely, by the way, include this on the video on Monday. A walkthrough of this program for you, definitely, for sure. Okay, dist fill, grab that, press enter again. What it's asking you to do is, it's going to build you the distribution. So let's say we're building my 4-bird flock. X is the number of girls in my 4-bird flock. What is the smallest number of girls I can have?
0.
None. Press 0. What is the largest number of girls I can have? 4. Then it asks you, what kind of random variable is it? I swear we'll go through this way more on Wednesday, I promise you. But right now, it's binomial. This is my language, my English language version. It's a binomial random variable. What is the chance per trial of a girl?
90.
I just put in 0.9. It says done. Go look at stat. Edit. There's your distribution for you right there.
That is so much easier.
Yes, and the reason, Haley, I gave you this gift is because once you get up to 10 and 20 and 30 birds, or 10 and 20 and 30 children checks for a peanut allergy, or 1,000, 2,000, 3,000 people surveyed for a poll, you do not want to do what we did today, as beautiful as it was today, it's an hour well spent. It's an hour well spent. But it is not 10 hours well spent. When you see what I'm saying? It's a great upfront cost. But now you understand where these numbers come from, except for the average, and then you get the average, right? Now you've got the distribution, you can run the average 1-bar stats to figure out your average that you need. Yes, my friend.
God.
But Kelsey's question and Elena's question still hasn't been answered, what that multiplier out front comes from. But do you see, you don't have to worry about that if you have this tool.
Yeah, if you have this tool.
And you do, and you always will. And you always, but the quiz in week 9, I promise you, I'll have an ordered quiz if you want to see where the numbers come from. It is mathematically beautiful. I'm not saying it's not. Okay, doke? Okay, friends, that's it for today. More on this binomial awesomeness.